All right, first let's talk about absolute value functions. We've solved absolute value equations before. We did that, remember, hopefully. All right, and so this is what the absolute value function looks like here as far as the equation itself. It's some absolute value plus or minus. Remember, when you solve, you need to get the absolute value by itself, and then you set up two equations, all right? The inside of this equation, mx plus b, what does that remind you of? And so what type of equation is mx plus b? It's a linear, so it's a line, right? And so what happens with absolute value is you have two lines that look like this, because it can equal the positive side or it can equal the negative, right? Now, with just an absolute value, so let's say you don't have this guy right here. We don't have the plus c. It's always going to be up here, always going to be right here. Because if you don't have the plus c, then your y value cannot go below negative, because absolute value can never equal negative. Now, if there's a plus or minus c over here, that changes it. Because a minus, you can have the absolute value, which is always positive, and then you subtract a number, and then yes, you can go into the negative. So the graphs can be anywhere on the coordinate plane. But if you just have this piece of it, and you don't have the plus or minus c, it's always going to be up here somewhere. Okay, always going to be up here. This is your basic absolute value function. It is just y equals the absolute value of some number x, all right? And so it looks like this. It is a perfect V. It has a 1 slope, so it goes up 1 over 1. See how it's walking up a perfect slope? And on the left-hand side, it actually has a -1 slope, right? So we have a perfect 1 over here as well, up 1 over 1. And so this is your main function here of your absolute value. Things can happen to my absolute value. You'll notice this is 2x minus 4. This 2 represents the slope, just like it does in a linear equation, right? So I go up 2 over 1, up 2 over 1, right? So everybody can see how that slope is the same on both sides, as it should be. You'll notice here I have a 1 slope. There's a 1 in front of my x, up 1 over 1. And then I have a plus 3, all right? And then in here I have a minus 3. And so you'll notice that it moved over here. So the pluses and minuses inside the equation shifted around the graph, all right? Some things about where you can find these things. The vertex, negative b over m. Negative b over m. That is my x value of my vertex. C, that is my y value of my vertex. So if I'm trying to figure out where on the graph this absolute value equation is going to be, I can use these to help me. The other thing I want to point out is what happens when we have a negative in front of it. A negative in front of it is going to point it down. All right, so instead of your V going up, your V is going to go down if there's a negative in front of it. All right, so let's look at actually graphing one of these. Let's look at this first example here. Graphing it. So we are going to figure out where our vertex is, and then we're going to figure out what our slope is. All right, so my vertex should be negative b over m c. So negative b over m c, that is my vertex. Now, it does not have a c, so that's easy. That's going to be 0, all right? Negative b over m, that's negative 12 over 3. So what is my x value?
4.
Right, so negative 4 is my x value. And so I know exactly where I'm going to put my vertex. I'm going to put it at negative 4, 0. All right, yeah, let's try this. There we go. All right, what's my slope? 3. So how do I move? Up 3 and over 1. And so absolute value is a little bit different. You're going to go up 3 and over 1 to the right and up 3 and over 1 to the left. All right? Because it is absolute value, meaning your slope is 3 and negative 3. And it just meets at that vertex. And then once you have that, you have your graph. I mean, you can just connect those points there and you can graph it. You don't need any other points once you figure out your vertex and your slope here for this guy. So once you figure out your vertex and your slope, you can just connect those and you have your absolute value graph. All right? Easy enough. Now, I will tell you, if you look at example 3 in your book, they teach you to create 2 different lines and then to graph them. I actually think that's more difficult, personally. I think there's more room for error when you do that. it's easier to me just to do a symmetry. These are always symmetric. And so if you can figure out one point, you can figure out the other one, because once you have your vertex and your slope, you kind of have it in place. All right. So